Hi everyone, welcome back to Science 9. This week we're going to continue our work with ionic compounds and we're going to go over how to write formulas of ionic compounds. So we're going to go over how to write formulas if you're just given the elements that are involved or if you're given the compound name. So here are some examples of some formulas we've already seen for ionic compounds: sodium chloride, magnesium chloride, aluminum chloride, lithium oxide, calcium nitride, and iron 3 oxide. So today we're going to go over how to actually write these formulas. So the first thing you need to know about writing formulas for ionic compounds is what those little numbers in the formula means. So those little numbers at the bottom of the elements, they're called subscripts. Those show how many atoms of that element are in the compound. Now, you'll see some formulas without numbers. If there's no number beside an element, that just means there's only one of those atoms in the compound. So like sodium chloride, there's no numbers in here. That just means there's one sodium atom and one chlorine atom in a compound of sodium chloride. Magnesium chloride, we see the little 2 down there. So that means there's 2 atoms of chlorine and only 1 atom of magnesium in magnesium chloride. Sodium oxide, this time the 2 is to the right of sodium. So there's 2 atoms of sodium, 1 atom of oxygen. Aluminum chloride, there's 1 atom of aluminum, 3 of chlorine, because the 3 is by the chlorine. Iron oxide, iron 3 oxide actually, so there's 2 atoms of iron and 3 atoms of oxygen. And then calcium nitride, there's 3 atoms of calcium, 2 atoms of nitrogen. So the difficult part about writing these formulas is you actually have to figure out what numbers to write and where beside the elements. So I'm just going to jump in, show you an example of how to do this, and then we'll work our way through some examples. So say I asked you to write the formula for magnesium chloride. We just saw it on the last slide, it's MgCl2, but how do we know to add that little 2? So to start, we know the only atoms that are present are magnesium and chlorine. We know that magnesium gives away 2 electrons and forms an ion charge of Mg2 plus from the periodic table. We know that chlorine likes to take 1 electron and it forms the ion charge Cl minus. So if we just tried to put 1 magnesium with 1 chlorine, that wouldn't be a good match because magnesium needs to give away 2 electrons to be stable. So magnesium needs to pair up with 2 chlorines. It gives 1 electron to 1 chlorine and another electron to the other chlorine. And now they're all happy in that compound. So 1 magnesium bonds with 2 chlorines, and that's why the formula is MgCl2. So just a general outline of how to write a formula, and then we'll do some more examples. So when you write the formula, we need to figure out how many electrons are being transferred. We need to figure out how many metal atoms are pairing up with how many non-metal atoms based on how many electrons are being transferred. So to start, always, so you're given a name or you're given the elements, look on the periodic table and write out the ion charge of both the elements present in the compound. And then we have to make sure that the charge is balanced, that the positives balance with the negatives, and they're the same. If they are the same, you could just write the formula as is. You just put the 2 element symbols together. But if they're not the same, then you need to figure out how many atoms of the metal are in the compound and how many atoms of the non-metal are in the compound to balance the charges. And I'm going to show you with some examples. So the first example we'll start with is calcium chloride. So like I said, the first thing you do, you write out the ion charges from the periodic table. So the ion charge of calcium is Ca2 plus, chlorine is Cl minus. So just looking at these, they don't balance. So we're going to need more than one atom of each of them. So I like writing them out in a table here. We notice that the right side, the nonmetals are -1, and the left side, the metals are +2. So if we add a second nonmetal, now the negative charges add up to -2. The positive charges are still +2. Here's a Bohr diagram of what that would look like. Calcium would give away 2 electrons, 1 to one chlorine, 1 to another. Now they're all happy. So we know there's 1 calcium atom and there's 2 chlorine atoms. So we write out the formula as CaCl, the little 2 down there. Another example, sodium oxide. Write out the ion charges. To balance them, we know we need more metals because this side only adds up to +1. We add a second atom of sodium. Now the charges balance out. What that would look like is 2 atoms of sodium each give 1 electron to oxygen. Now they all have a full outer shell. And the formula, we know there's 2 atoms of sodium, so Na2, 1 atom of oxygen. So we just put the O there. Aluminum fluoride, write out the ion charges. Aluminum forms a charge of +3, so we're going to need 3 fluorines to balance that out. So this atom of aluminum would give an electron to this fluorine, 1 electron to this fluorine, 1 electron to this fluorine. So the formula is there's 1 aluminum, so Al, there's 3 fluorines, so F3. Another example here, calcium nitride. This time these get a little tricky if one gives away 2 and one accepts 3. So to balance these here, if we add a second atom of calcium, that would give it a charge of +4. That wouldn't balance a -3. But if we add 3 atoms of calcium and 2 atoms of nitrogen, now they balance. They both form a charge of 6. Here's a Bohr diagram of that. So basically, this calcium gives 2 electrons to this nitrogen. This calcium gives an electron to this nitrogen, so it's full, and then an electron to this nitrogen. And this calcium gives its 2 electrons to this nitrogen, and they all balance. So to write this formula, we see we have 3 calcium, so it'd be Ca3. And we have 2 nitrogens, so it would be N2. I'm going to show you guys a shortcut called the crisscross. I call it the crisscross anyway. It works about 90% of the time. So with this previous example here, the ion charge of calcium, so the number above calcium, is how many nitrogens there's going to end up being. And the number above nitrogen is how many calciums there's going to end up being. It's a little shortcut. I'll show you an example when it doesn't work, but there's a simple fix to that. Calcium oxide. So if we look, if they have the same charge, so Ca2 plus O2 minus, this doesn't work. So because 2 calciums bond with 2 oxygens, that actually means that just 1 calcium bonds with 1 oxygen. So the way to get around this is we just reduce to CaO. So if you ever do the crisscross but the numbers are the same, or if this was like a 4 and a 2, you just reduce them. So CaO. So I'd like you guys to pause the video here, do these practice problems in the book. The answers are either on page 509 or the next slide, which I'm going to show you now. Next, we're going to talk about how to write formulas using multivalent metals. So we went over multivalent metals when we were naming compounds. They're metals that can form more than one ion charge. Naming with these is actually way harder. When we write formulas, we already know which ion is used because it's in the name of the formula. It's given by the Roman numeral here. So an example of this, if we had to write the formula for manganese 3 sulfide, we know by the Roman numeral 3, it's Mn3 plus. And then sulfur is always S2 minus. So it's Mn2S3. Another example, copper 2 chloride. Copper can either be 2 plus or 1 plus. Because it's copper 2, it's a copper 2 plus. So the formula is there's 1 copper and there's 2 chlorines. So CuCl2. So again, some more practice problems from your textbook. Answers are on page 509 or the next slide. So pause here. And here are the answers. Okay, and the last thing we're going to go over is how to write formulas with polyatomic ions. So remember polyatomic ions, they're covalent compounds that have an overall charge. So carbonate, sulfate, phosphate, nitrate, ammonium. I'm going to show you a table of these on the next slide. You already have that table, but I'm going to show it to you again. Remember the subscripts, they're just part of the compound. So carbonate, the subscript 3 just means that compound has 3 oxygens. But when we write the formulas, just like when we named them, treat them as one element. So here's the list again. So I'll show you an example here. How to write the formula of potassium nitrate. We know potassium is K plus. Nitrate from the chart is NO3 minus. Because this has a charge of +1, this has a charge of -1, 1 potassium just goes with 1 nitrate. So the formula is just KNO3. Magnesium hydroxide, we write out the ion charges. Magnesium has a charge of +2. Hydroxide has a charge of -1. So that means we need 2 hydroxides to balance with 1 magnesium. Now, when we write the formula, we know there's 2 hydroxides. The only thing different we have to do with polyatomic ions is if we're adding a subscript to show there's 2 hydroxides, we have to put brackets around it. If we didn't put brackets, if it was MgOH2, that 2 would just mean there's 2 hydrogens and only 1 oxygen. Because we have the brackets, we show that there's 2 hydroxides. There's 2 oxygens, 2 hydrogens. Magnesium phosphate, this will be the last example we do. Magnesium forms a charge of +2. Phosphate forms a charge of -3. We balance these out. We know that there has to be 3 magnesiums for every 2 phosphates to get +6 and -6 charge. So the formula is Mg, we put a little 3 beside magnesium, PO4, and because there's 2 of them, we put a bracket around it to separate the 4 and the 2. PO4, 2. That's as hard as it's going to get. And I just want to kind of compare that to magnesium phosphide with magnesium phosphate. So we did this example, magnesium forms a charge of Mg2 plus, phosphorus P3 minus. So we would just crisscross those. It'd be Mg3P2. So that's simple enough. So if we did that instead of with phosphorus, with phosphate, same charges, we crisscross it. There's still 3 magnesiums for every 2 phosphates. It's not much different, it just looks a little different. So I'd like you guys to do one final set of questions. So pause here. Here are the answers. here are some helpful videos, and here are the assignments for